the future of artificial intelligence may not be on Earth. For decades, we believed that the most powerful computers in the world would always be built on land. Massive facilities filled with servers, cables, cooling systems, and an endless demand for electricity. But today, that assumption is being questioned. Elon Musk recently claimed that within the next 36 months, outer space could become the cheapest place to host artificial intelligence systems. At first, this sounds like science fiction. Space is dangerous, remote, and incredibly expensive. But for machines, not humans, space might actually be the ideal environment. On Earth, data centers face constant limitations. They require enormous amounts of power, vast quantities of water, and complex cooling infrastructure. In some regions, a single data center can consume as much electricity as an entire city. Cooling alone can account for up to 40% of total operational costs. In space, many of these problems disappear. Above Earth's atmosphere, sunlight is almost continuous. There are no clouds, no weather systems, and no seasonal changes. Solar panels in orbit can receive stable energy for most of the year, far more efficiently than panels on the ground. And then there is cooling. In the vacuum of space, heat can be radiated away without fans, water, or industrial air conditioning. What requires massive infrastructure on Earth could be handled naturally in orbit. According to documents filed with the Federal Communications Commission, SpaceX is exploring a system that could eventually involve up to 1 million satellites. These satellites would not only provide connectivity, but also host powerful AI computing hardware. Imagine this for a moment. Instead of data centers hidden in deserts or underground facilities, there will be orbital platforms silently circling the planet, processing information, training models, and supporting global AI systems, all from space. But this vision comes with consequences. Reports from the Wall Street Journal suggest that SpaceX has shifted its priorities. A previously planned uncrewed mission to Mars, originally targeted for late 2026, has been delayed. Instead, the company is focusing on a moon landing scheduled for March 2027. Elon Musk has admitted that while a Mars launch this year remains technically possible, it is unlikely. This decision reveals something important. Resources are finite. Every launch, every rocket, and every engineering team can only focus on one goal at a time. Investing in orbital AI infrastructure may accelerate technology, but it can slow humanity's expansion deeper into space. At the same time, Musk confirmed the merger of SpaceX and xAI. Valued at over $1 trillion, this union is designed to create a single innovation engine. In this model, Starship rockets would transport massive computing systems into orbit. Once deployed, these systems would power xAI's models, including Grok, with near unlimited energy and cooling. Artificial intelligence would no longer be constrained by the physical limits of Earth. But technology is only part of the equation. Musk has openly acknowledged a growing human challenge. Recruiting engineers has become increasingly difficult. Convincing talented people with families to relocate to SpaceX's Texas facilities is not easy. He has described the environment as a technological monastery, a place that demands total focus, long hours, and personal sacrifice. This raises a deeper question. Machines can operate in space indefinitely. Humans cannot. As AI infrastructure moves off-planet, the gap between human limitations and machine capabilities continues to grow. There are also serious risks. Launching thousands or millions of satellites increases the danger of orbital debris. Maintenance becomes far more complex. Failures are harder to fix, and legal questions remain unanswered. Who regulates data centers that orbit above every nation? Who controls AI systems that exist outside traditional borders? Space-based AI offers enormous advantages: constant energy, lower long-term costs, and unprecedented scale. But it also introduces risks that humanity has never faced before. This is no longer a distant future. It is an engineering choice being made right now. And within the next decade, we may discover that the most powerful intelligence on Earth does not live on Earth at all, but in orbit.